Good morning, everyone. My name is Manuel Gonzalez. I'm assistant professor in the University of Sevilla in the Department of Aerospace Engineer and Fluid Mechanics. And it is a shared work with the Azud, a business there in Alcantarilla, Spain, and with the CSIC too, with Francisco Salcedo Pedrero. I would like to share with you the application of SUDIPRO. SUDIPRO has a copyright because it belongs to the business Azud. And we use the SUDIPRO software as a support tool for management of the wet bulb in the localized irrigation with reclaiming water or whatever other kind of water. Here is a quick roadmap of what we'll cover. We'll start with a quickly view of a background water scarcity and the role of reclaimed water in the Mediterranean area, and moving very quickly onto the regulatory framework. And we are focused in the file of the study, a grape orchard in Campotejar, Murcia. We are talking about the cases that we are studying. And then we come the result of the model analyzation, the statistic area squared and the root mean square error too. And afterward, we are going to conclude with a summarize of some conclusion about the wet bulb confinement as a sanitary and environmental indicator. Very quickly, because all of you we are talking about this topic, reclaimed water has become a strategic resource for irrigated agriculture, but its safe use requires carefully hydraulic management that goes well beyond meeting basic quality threshold. We don't talk about quality, the water quality. We are going to talk about how can I manage the water. This is the subsurface drip irrigation, or SDI, Cummins, and it is offered a high water use efficiency and delivers water precisely to the root zone. What makes it so important in the context is that it casts a prevent barrier limiting contact between reclaimed water and the crop surface. Besides, if the wet bulb rise to the surface, it creates a sanitary risk through direct contact. And if it extends too far downwards, it creates an environmental risk too, through the deep percolation through the groundwater. Really, the safe zone is that confines the wet bulb around 0.35 meter through. When we talk about regulation, we begin with the regulation 2027/41 from Europe and the modification. Our last Royal Decree 2087. Now we have a new regulation with the 1085/2024, where we start to talk about accredited barriers. We have the Annex 3, I think so. This is the Annex 3, where we talk about accredited barriers. In this sense, use a tool as SUDIPRO. It could be a good tool for managing the risk correctly. Irrigation design must be prevent hazardous events and control surface weighting, excessive percolation, salinity building up, and potential groundwater impacts. And here is the key mention, or the key point. Only with a tool capable of predicting wet bulb geometry and identification potential surface emergent or deep percolation could be a good tool to save operation and to be guaranteed. I'm going to introduce the Sudipreo model and how this software works. Really, the software is designed for a practical, usable, not advanced modeling expertise is required, and it combines realism with practical usability by passing the step learning course of advancing numerical model as IDRUS. I don't know if you are useful to use this kind of bidimensional models as IDRUS, but this is work very similar with another kind of algorithms, but very similar. At the end, the objective is if we can predict or control the wet bulb, you can prevent reclaiming water from percolating into the groundwater or avoid the water rising to the top of the soil, to the soil surface. This is a simple draw to show how work the modeling, the wet bulb around the pipe, the surface pipe, and around the trees. We need for the input that we need to feed the Sudipro are three pillars. Soil characteristics, texture, hydraulic properties, the irrigation system configuration too, how is our emitter flow rate, deep, spacing, operational parameters, duration and frequency of the irrigation too, and the algorithms in Sudipro simulate the spatial and temporal distribution of the water in the soil profile and estimates the wet bulb geometry, deep, with vertical distribution, together with a qualitative assessment of irrigation performance. The outputs that we generate with Sudipro algorithms are, for example, the wet bulb depth, the distribution, the surface wearing risk indicator, the deep percolation warning too, and a root zone overlap assessment. As this digital wet bulb simulation show, for this particular case, we get a wet bulb radius around 0.45 meters, with the drip line separate at 0.30 meters deep, and the moisture content in the soil about 30%. The file of the study was in Murcia, in Campotejar. We received the water of Molina de Segura wastewater treatment plant. It's a huge wastewater treatment plant with industrial water too. And this is important in the study. We have designed. We studied the grape fruit, star rabbit, planted at seed by 4 meters spacing. The localization, as I said before, is Campotejar in Murcia, a semi-arid area. The soil is loam 20. This is the characteristics there. Yes, 24% clay, 33% silt, and 43% sand. And we use a double line, lateral line per row with emitter flow 2.3 liters per hour. There is, and the emitter depth is about 0.55 meters surface. What is interesting about this design that by focuses on a single crop, on a single soil type, and a single irrigation system, we can compare wet bulb dynamics very consistently, minimization variability association with the external factors. We used to drive and roll capacity probes to give information about the wet front is advancing, go down in the soil, in the section of the soil. Here is a draw that we explained. We can see the explained before. We designed 2x2 experiments on the water source axis transfer water. When I say transfer water, really is the fresh water. Transfer water is the particular water that we transfer from the Tajo basin to the Segura basin. It's a good quality water with electrical conductivity about 1 decision meter. We use this kind of water and the other water, reclaiming water for the wastewater treatment plant of Molina de Segura, with electrical conductivity much over 30 decision meter. And we analyzed two kind of management of irrigation: full irrigation versus regulated deficit irrigation, or RDA. This is the study. In this way, the soil water dynamics are primarily governed by the soil hydraulic properties, with a limited short-term influence from the water quality. If water quality had a strong short-term effect on the wet bulb dynamics, we would expect to see clear difference between case 1 and case 2, and on the other hand, the case 3 and the case 4. And as well, we will see in the next slide, in the result, that is not the case. In this table, summarize model performance for the 4 cases. We analyzed the irrigation in the first 6 hours and after in the 24 hours, analyzing 2 statistic parameters, R square and RMSE. What this table shows at a glance is that the model performs well across the board, and that this performance improves even further during 24 hours distribution phases. In case 1, full irrigation with fresh water or transfer water at 6 hours after irrigation, we can see that R square is around 0.73. Here is the case 1. And afterward, when past 24 hours and the water in the matrix of the soil start to stabilization, we have a R square much better, around 0.83, and RMSE about 5.7%. In case 2, when we use regulated deficit irrigation, the movement of the water inside the matrix of the soil, it's more homogeneous in 6 hours and in 24 hours. Case 3. Well, here is an imaging of how is the water around inside the matrix of the soil. And in case 3 and case 4, we can see that at 6 hours, R square is very clear to 1, and RMSE is quite down 2 in both cases. And here the spatial distribution is very comparable to case 1. We transfer, in other words, the infiltration process is not significantly affected by the water quality at short time scale. This is clear. It's not dependent on the quality of the water. After, at 24 hours, we reach the best result of the entire study, very close to 1 R square, and RMSE about around 3.6%. The wet bulb here shows similar depth and geometry to the case 1, confirming that the reclaiming water does not alter the hydraulic behavior of the soil under this condition. Well, this is a summarized graphic, all the cases, and the kind of finding that we find. Reclaimed water show comparatively to the better perform versus transfer water, as I said before. The last idea, SUDIPRO as a preventive risk managing tools. As I said at the beginning of the presentation, from an environmental perspective, limiting the downward movement water, salt, and nutrient reduce the risk to groundwater contamination. Wet bulb confinement is itself evidence of a good hydraulic control. From a sanitary perspective, preventing surface wearing limits contact with reclaiming water. SDI acts as an additional preventive barrier, as our regulation using the next 3. Protecting the crop, this shield or this barrier, protect the crop surface, workers, and bystanders. What SUDIPRO ultimately offers is a bridge between regulatory principles, irrigation, engineering, and day-to-day decision-making. Verified hydraulic control. In conclusion, in summarize, SUDIPRO demonstrates consistent and reliable performance in reproducing wet bulb dynamics across all 4 irrigation cases. The second one, what this result confirms that this model accuracy improves during the distribution phases, 6 to 24 hours, which is precisely the most operationally relevant window for irrigation scheduling. The third is an irrigation strategy, full versus RDA, primarily affects soil moisture magnitude, wet bulb geometry remains largely unchanged. The fourth is here is a strong inversion to close this point. Under no circumstance did we observe significant difference in wet bulb geometry between reclaimed and transfer water under similar hydraulic condition. It is the soil's hydraulic properties that the really dominant parameters. And the last one, SUDIPRO verifies wet bulb confinement and can anticipate surface wearing and deep percolation risks, supporting safe, regulatory compliance, reclaimed water reuse. And this is all. Thank you very much.